Hi everyone, and welcome to today's webinar, Protecting Your Spring Boot Applications from Recent Critical Vulnerabilities, sponsored by PreEmptive. I'm Jenna Sargent, news editor of SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website about 24 hours after the event. Secondly, if at any time you have questions about the presentation, you may submit them using the chat. Now moving on to today's webinar topic. Spring Boot is a common framework for building Spring-based applications, but all frameworks have their risks, and Spring Boot is no exception. Recently, zero-day vulnerabilities in the Spring framework and Spring Boot have created increased demand for security for Spring Boot. For example, Spring Boot was recently impacted by the SpringShell vulnerability that affected the data binding mechanism and made many applications vulnerable. In this webinar, you'll learn how you can use PreEmptive Dash0 to ensure confidence in the security of your Spring Boot applications. Our speakers today include John Bronner, Senior Solutions Engineer at PreEmptive, and Michelle Pruitt, Digital Marketing Manager at PreEmptive. Now, on to the webinar.
Thank you, Jenna, and everyone who is joining the webinar today. Today, there are over 7 million apps across iOS and Android platforms. According to resources, 21% of people open an app 50 times per day, 49% of people open an app 11 times each day, and 70% of all US digital media comes from mobile apps. With the increased dependency in mobile devices and applications, it is no surprise that these have become easy targets for threats. While hackers have dominated attacks to desktop applications, they have found easier ways to get creative through interjecting mobile applications. Since 2019, 70% of online fraud is accomplished through mobile platforms and various apps, and this number has increased. But as tech evolves and new environments are developed to make builds easier for developers, these too are subjected to vulnerabilities. For instance, developers utilizing builds on Spring Boot have many beneficial aspects, but one thing it lacks is automatic security features. While the Spring framework does have some simple security options, they aren't particularly thorough. But before you implement the tool in your next application, it is essential to understand the potential drawbacks of Spring Boot and how to mitigate them. With an increase in organizational mobility typically resulting in an increase in the number of mobile devices and applications, means a growing variety of endpoints and threats you need to secure in order to protect your organization from a data breach. In this webinar, we will be discussing an overview of Spring Boot and the types of critical vulnerabilities, along with how PreEmptive Dash0 supports Spring Boot as part of best practices in in-app protection. So let's take a look at our agenda. We will be discussing an overview of Spring Boot and SpringShell risks, PreEmptive Dash0 now supporting Spring Boot, a Spring Boot security demo, along with a Q&A at the end. If you develop web or cloud applications in Java, you've probably heard about Spring Boot. This convenient tool is found in a huge range of Java applications, supporting them and keeping them running. However, if you have never worked with Spring Boot before, it is not always immediately apparent what it is or how it works. Spring Boot is a tool designed to make it easier to write applications that run through the Java Spring framework. The Spring framework is an open source Java framework designed to help enterprises develop standalone applications. The framework is structured to support applications for Java Virtual Machine, or JVM, installations, and Spring Boot makes that process simpler by offering 3 critical features for app developers. 1, it supports the standalone nature of the Spring applications. It implements automatic configuration of Java libraries when possible. And last, it provides an opinionated set of starter configuration beans for apps. And with the ease of Spring Boot features, it is no surprise this is most commonly used for web and cloud applications. GitHub is full of excellent examples of Spring Boot applications, such as web applications. The Spring.io website has been built using Spring Boot, so it perfectly demonstrates what the tool looks like in action. The code is up on GitHub, so anyone can explore how the tool was used to simplify the site setup. And IoT applications. Spring Boot can kickstart IoT applications. It is a great example of how the tool can be used for IoT programs, such as the XOR Talk library, which can be quickly added to any Spring Framework project to connect the app to Microsoft Azure and Amazon Web Services IoT offerings. Mobile security threats are commonly thought of as a single, all-encompassing threat. But the truth is, there are different types of mobile security threats that organizations need to be aware of. Mobile application security threats. These application-based threats happen when the people download apps and look legitimate, but actually skim data from their devices. Examples are spyware and malware that steal personal and business information without people realizing it's happening. Web-based mobile security threats. Web-based threats are subtle and tend to go unnoticed. They happen when people visit affected sites that seem fine on the front end, but in reality automatically download malicious content onto devices. Mobile network security threats. Network-based threats are especially common and risky because cyber criminals can steal unencrypted data while people use public Wi-Fi networks. And last, mobile device security threats. Physical threats to mobile devices most commonly refer to the loss or theft of a device. Because hackers have direct access to the hardware where private data is stored, this threat is especially dangerous to enterprises. As stated earlier, Spring Boot isn't perfect, and the environments like these don't come with the best security features. With the evolving sophistication of attacks, it's essential to understand them and the potential mobile risk associated with application development. Let's take a look at one of the most critical vulnerabilities found in Spring Boot. Researchers have discovered a critical vulnerability CVE 2022-22965 in Spring. This vulnerability immediately attracted the attention of information security specialists as it potentially poses a serious threat to many web applications. Similar to Log4Shell, this new vulnerability was named Spring4Shell. But the most pressing question are, what exactly is Spring4Shell and why is this vulnerability fatal for developers? First, the vulnerability belongs to the RCE class. That is, it allows an attacker to remotely execute malicious code. And currently, its severity is 9.8 out of 10. The vulnerability affects Spring MVC and Spring Webflux applications running under Java Development Kit version 9 or later. While the discovered vulnerability was reported early and proof of concept for the vulnerability was published, the POC was quickly removed, but not until it was noticed by security experts, some of whom which confirmed the danger of the vulnerability. And it's very unlikely that such a potent exploit has gone unnoticed by cyber criminals. The Spring framework is quite popular among Java developers, and this means that many applications could be vulnerable. According to resources, Java applications vulnerability to Spring4Shell could become a cause of compromise for a huge number of servers, but the vulnerability is already being actively exploited. But along with this critical exploitation, there are other mobile application threats to be on the lookout for. Since last year, the number of mobile malware attacks saw a significant drop, but the attacks were much more sophisticated. In some cases, malicious code can be loaded into popular mobile apps through advertising SDKs, otherwise known as a Trojan. Cyber criminals have also managed in many cases to deliver their malware and scammy applications through Google Play and other official app stores. Along with these types of critical exploitations, there are other mobile application threats to be on the lookout for, such as the following: social engineering. Social engineering attacks are when bad actors send fake emails, or phishing attacks, or text messages, smishing attacks, to your employees in an effort to trick them into handing over private information like their passwords or downloading malware onto their devices. Next, data leakage via malicious apps. 85% of mobile apps today are largely unsecured. Hackers can easily find an unprotected mobile app and use the unprotected app to design larger attacks to steal data, digital wallets, back-end details, and other juicy bits directly from the app. Next, unsecured public Wi-Fi. Public Wi-Fi networks are generally less secure than private networks because there's no way to know who set the network up, how, or if it's secured with encryption, or who is currently accessing it or monitoring it. And as more companies offer remote work options, the public Wi-Fi networks your employees uses to access your servers, whether they're from coffee shops or cafes, could present a risk to your organization. Next, end-to-end encryption gaps. An encryption gap is like a water pipe with a hole in it. While the point where the water enters your user's mobile devices and the point where the water exits the pipe, your systems, might be secure, the hole in the middle lets bad actors access the water flow in between. Unencrypted public Wi-Fi networks are one of the most common examples of an encryption gap, and it's why they're a huge risk to organizations. Since the network isn't secure, it leaves an opening in the connection for cyber criminals to access the information your employees are sharing between their devices and systems. And last, IoT devices. The types of mobile devices that access your organization's systems are branching out from mobile phones and tablets to include wearable tech like an Apple Watch, and physical devices like Google Home or Alexa. And since many of these IoT mobile devices have IP addresses, it means bad actors can use them to gain access to your organization's network over the internet if those devices are connected to your systems. Knowing where the threats lie is key to prevent catastrophic breaches from happening, both in development and after. Moreover, it's important to have proper protection built into your program to avoid these risks, and you'll need to continually update your app's security wherever new threats appear. So how can you protect your applications? The solution is to implement your own in-app security. While certain environments do have security options, this won't protect you fully. Hardening your app against security threats requires you to include features like obfuscation. If your app contains any kind of private data, it needs to have obfuscation features. You should look for app security solutions that offer multiple forms of obfuscation, such as renaming, encryption, and control flow. This will help you protect everything from login credentials to personal user data. Runtime checks. It's just as important to ensure your applications aren't tampered with. Runtime checks let your applications confirm whether or not they have been altered before they start any sensitive tasks. Furthermore, they can help you shut down the app if any unauthorized tampering occurs, helping you avoid data loss. Regular updates. If you want your app to remain safe in the future, you must implement a security solution that will stay up to date. The best security solutions automatically update to continue protecting your applications whenever new threats appear. So if you're in the need of fast security solution, that's where PreEmptive Dash0 can help. With this new release, we have overhauled and enhanced support for Spring Boot and Java web applications. In the latest update, our development team has rolled out some new enhancements, changes, and bug fixes. What does our version 11.3 include? It includes enhancements. Our Dash0 can now accept war and jar files as Dash0 output. Dash0 now directly inputs mobile, web, and desktop applications without manual steps. Complete obfuscation support for Spring Boot. Bug fixes. Validate modifiers input fields in the config editor for include and exclude rules. And last, new option for properties with file system path values to open a system browse dialog. Now that we discussed Spring Boot, the vulnerabilities associated with it, we will now hand it over to Senior Solutions Engineer John Bronner for the preemptive demo.
Thank you, Michelle, and thank you all for joining us today. Threat modelers instruct us to create layers of defense against potentially exploitable vulnerabilities. Data breaches typically happen because of a combination of flaws that have been exploited by hackers. Server misconfigurations, insecure coding practice, imprecise access control or authorization, and binaries not effectively hardened or shielded against reverse engineering. At PreEmptive, we focus on neutralizing the threat of reverse engineering and tampering. With nothing more than deployed binaries or our apps distributable, hackers can do everything from stealing your intellectual property or trade secrets to probing for vulnerabilities or bypassing software checks like logins or license key checks. We've worked with Spring Boot project for many years. Dash0 runs on the bytecode, so we could always process Java bytecode. but there was a handful of manual steps to provide the input in a format that Dash0 would accept. And then from there, we had to manually repackage in a format for deployment, be it the Spring Boot jar or WAR. The work that we've done has been to natively support the Spring Boot format. Spring Boot jars or WARs package jars within jars, and it has a very particular structure. It also has a specific set of entry points for its startup sequence other than our standard main method. The work we've done of late eliminates any sort of manual steps or processing of the Spring Boot jars and WARs. Let's take a quick minute to walk through our very simple Spring Boot sample application. I'll start our WAR file, which normally runs on our web server. Next, I'll start our desktop, our client piece. When I first start the client, I have to authenticate. I do need to provide a valid username and password. My authentication does work. Okay, after successfully logging in, successful authentication, I'm able to use the application, which basically just exercises our REST API with basic CRUD operations. I want to change last name, do a quick update. If I need to delete a person, that's basically it. That's our demo app. It's got our server-side piece, which was built using Spring Boot, and then our client piece, which exercises the API and performs some pretty basic CRUD operations. Now let's put on our hacker hats. With no source code, nothing up my sleeves, we'll reverse engineer and tamper this app as a theoretical starting point for a data breach. To do this, I've downloaded a free decompiler tool called Bytecode Viewer. There are between 4 and 6 decompilers that are actively maintained in the Java space. So there's JD GUI, DJ Decompiler, KavaJ, Fernflower. All of them do pretty much the same thing, which is extract and decompile to render the high-level Java from the jar file, WAR file, or APK. By using the bytecode viewer decompiler, I can see classes and methods and browse their algorithms. I could drill down and see the backend API that is called on button save or button save handler. I could take this API name into a tool like Postman or curl, since it's in the clear. And in this case, I could directly probe and discover further API functionality. I could bring it even directly into the browser, could play with the headers. There's all sorts of things I could do just by seeing this code in the clear. And furthermore, by running the application, we noticed that a login is required each time. The login is supposed to control access to the features that are calling these APIs and exercising the functionality. But all of the functionality of this app, including the login functionality, is embedded within the distributable, so it can be easily accessed through decompilation. Although the authentication mechanism works, it's pretty easy to bypass. I see here that the CRUD class, which is my main class with all the UI controls and buttons and handlers and that sort of stuff, it also has a main. So I'll see if I can just bypass the login by resetting our main method of the CRUD class as opposed to the user login class. All right. There's my tampered jar. And when I run that tampered jar file, I see that I was no longer presented with a login screen. And so all I did there is I didn't even have to manipulate the decompiled code. All I had to do was do a little misdirection and set the entry point of the CRUD class, which is exercising the API. And normally the server-side control will be running, so I would be seeing the user data and I would be able to continue on using the features of the app. From our server side, we can see that we could just as easily decompile and open our WAR file in the bytecode viewer to see how we're initializing the data on the server side. It is more likely that we will be exploited by our client-side app, but if our WAR file is, let's say we're distributing a turnkey app, we're providing a turnkey to our customers, or we have a third-party hosting service or a cloud server, or if we're concerned about an inside job, let's say the people deploying the app or those with access to our servers for maintenance are not necessarily the people writing the code. According to research, about a quarter of data breaches are started internally. So whether that's just just a carelessness or what have you, or deliberate maliciousness, a good portion of data breaches do start from internally. So it is critical that we secure our server-side code as well as the client pieces. All right. In order to protect our jar file and our WAR file against decompilation or reverse engineering, I've installed PreEmptive Dash0. All of PreEmptive tools are cross-platform, so we're currently running a Windows development environment, as we see here, but we can run Dash0 identically if we're developing on Mac, or if we're doing our builds on Ubuntu, or for example, Dash0 has a command line interface, a standalone GUI, Ant, and Gradle integrations. In this case, I've loaded my jar directly into the Dash0 graphical user interface. Following the layered approach, Dash0 offers several obfuscation transforms we could take advantage of. Certain transforms like control flow, rename, and string encryption are pretty much universal. Others will work better in different contexts. So, for example, if we were distributing part of the app as a separate API or SDK, we might leverage the removal transform to strip out the unused portions of code from the distributable, thereby decreasing the surface area for attack. Also, or another example is if we're deploying the mobile app, we'd want to inject a root check or a jailbreak check or a hooking check. For this initial Dash0 build, I'm going to enable only our tamper check, so we can protect against direct manipulation of the jar file. This tamper check triggers when we click the handler for the update button. So if the jar has been compromised, then we can detect that when somebody clicks the button update. And in this case, I've configured a response that exits the app if the app has been tampered in any way. We can add checks in multiple places throughout our app's execution lifecycle, and we can wrap our responses in any custom code. So in this case, these are out-of-the-box responses: exit the app, hang the app, throw an error, an exception. But we can any custom code can be configured upon any of the checks. So if we wanted to, we could do a call home, do custom logging. We could disable UI controls of our app. We can brick the app, erase the hard drive. It's totally up to you. All of that functionality is control is given to you as well. All right. So let's do our initial Dash0 build with only our tamper check. Reload our decompiler tool. Okay, and I have not applied any obfuscation, so the names are still in the clear. But if I'm going to export a runnable jar, and then try and do that trick where I adjusted the entry points to bypass the login. Okay. If I look at the version that is run through Dash0 with my tamper check, go ahead and launch that. The app launches and it does go end around of the login, but if I try and click the update feature, then the app just shuts down because in this instance, it's been tampered. All right, so now that we've verified our tamper check, let's go ahead and layer in more protections. I'll go ahead and enable removal because removal, like I said, it's more of an optimization where we can strip out unused code. We can strip out unused debug information. No reason for anybody to be trying to debug our app once we've gone to production. Any annotations that we're using that are not needed at runtime. In addition, we can figure removal. So all of the transforms of Dash0 can be configured. We have full granular control. So at the package level, all the way down to the class method field. So let's say for this third-party component that's embedded within my client jar, I don't want to do any removal or control flow. I can configure a rule for that. I could configure rules for individual methods. I can write pattern rules to apply for larger coding patterns if I want to do my configurations around that. Full control over these settings. We also have a method call removal. So we developed this feature specifically around user feedback, wanting to be able to strip out certain logging from their production app. So let's say we don't have any reason to include logging of informational messages in our production app. We only want error warning and critical or above. We could strip out any calls to just basic logging messages. We could do that. Then I'm going to go into my control flow and enable that and make sure I have that set at the highest setting. Default is a bit low. I can also play with the target block size so I have more overall blocks to play with. Renaming, I'll go ahead and enable my overload induction renaming scheme to apply even more renaming within our app. I can randomize the renaming. I could use different identifiers to make it even tougher to understand the code by the decompilers. I'll turn up my string encryption all the way to the top level, and synthetic. If I want to introduce the synthetic keyword, then introducing the synthetic keyword will tell certain decompiler tools that that particular method or methods are compiler generated. So if it thinks it's compiler generated, it'll just skip trying to decompile it altogether. Bytecode optimization, certain opcode removal or superfluous bytecode can be stripped. Make public if we do rename and collapse package designations, we can make certain classes or members public so that access modifiers still work after obfuscation. Pre-marking, if we wanted to embed a watermark within our jar, a unique watermark, we have all that ability as well. And again, with all these transforms, we have full control to include or exclude via pattern, via rules, and we have full control is put in your hands after the initial setup for doing your own custom configurations. All right, so let's go ahead and do our second build. All right, our build is completed. And now let me go ahead and load that obfuscated jar into my decompiler tool. And what I'll see here is that a lot of the identifiers have been renamed. If I drill down into individual classes, then I should see a good amount of scrambling going on here with the code itself. So obviously, the more code within a given class or package, the more obfuscation will be done overall. But if I look at any class with any sort of IP within it, it should be completely cloaked. Names of identifiers are changed so that if somebody's trying to peek at our code in a decompiler disassembler tool, they won't be able to make sense of this, and they won't be able to use this as a starting point for their data breach. All right, so now that we've secured our client-side piece, we'll add Dash0 to our WAR file to secure our server-side component. All right, when we first start Dash0, we're presented with a Dash0 wizard. The wizard aims to guide us through our configuration based on our project type. So we see if we're doing something for mobile, we're doing something with desktop, we're building specifically a library, or a web application, which is what we're doing here, a Spring Boot, jar, or WAR, or just a regular WAR file. I'll browse to my WAR file. I also have to set my JDK home. Dash0 uses the JDK as during its analysis. And from here, the rest is pretty much a next finish. The other nice thing about the wizard is, talked about a little bit before, it's the wizard's analysis helps us to identify those entry points. So each entry point will be different if we're building a mobile, desktop, or web, obviously. So if we're building an Android mobile application, the entry points would be different, and that impacts how we go about the obfuscation and securing of the distributable. You see Dash0 automatically selected those custom entry points, this being a WAR file. And again, the rest is just a next finish. And I'm going to do the same for our WAR file that I did for our client app, which is just go through the settings and tweak those. Okay, so first thing I'll do, we see the control flow options are relatively conservative, so I'll bump those up. Same with string encryption, we're relatively conservative in terms of how we're applying these settings, so I'm going to go ahead and be a little bit more aggressive in terms of how I apply my obfuscation. And then I'm going to go ahead and save my project and do a build. As the build proceeds, we draw our attention to the console window here. Dash0 is basically doing a full analysis of disassembly, reassembly, while applying the code obfuscation in between. So if there is any sort of issue with the processing of the jar file or WAR file APK, we try and issue meaningful warnings, errors, or informational messages so that we can take action. We have a full reference troubleshooting guide if we do run into any sort of problems during the analysis or obfuscation phase. All right, and I see that my build has finished. The cool thing about this is we noticed that Dash0 inputted the WAR file and it output a WAR file for us as well. Just to harken back to something we said previously, before the work that we did for the Spring Boot project, we would have to extract this WAR file and feed the directory of classes for obfuscation and then repackage those classes. So there was a lot of room for error, a lot of manual steps. In this case, input, output, obfuscated files. And then if I were to take the WAR file to my decompiler tool and expand some of the classes, I would notice that the WAR file has also had obfuscation applied as well, so I wouldn't be able to just drill down and see exactly what's going on in the classes themselves. All right, so I've secured my WAR file, I've secured my client-side piece. Equally as important is I need to be able to run the obfuscated bits. Okay, so I'll start up my WAR file. Okay, and then I will start up my jar file. Okay, so we can see that even after code obfuscation, the output is running equally, identically, as it did to my inputs. All right, so there you have it. You can see, we've seen how with just a few clicks within a free decompiler tool, a hacker could easily compromise our app with just the distributable. And with pretty much any language that's out there today, there is some sort of decompiler or disassembler that is available. So whether we are doing Java or we're doing .NET or even a native app, Objective-C, there are decompilers that exist. So with these tools, not only can the hacker browse the source code and potentially steal our super secret algorithms, but as in this case, they could take it a step further and modify functionality to change the behavior of our app. We all follow coding conventions and naming patterns that are our friend during the development process. We start with our main method, onCreate method or render function, and then we construct meaningful names and follow object-oriented principles. But clean and easy to follow code is also easy for a hacker to follow and can be used to exploit our app. This is a pretty basic example, but in our production-ready app, a similar exercise would potentially uncover clues as to how we connect to the backend, how we're connecting to data, or otherwise how we've constructed our mega awesome app. With preemptive code obfuscation, we destroy those patterns that are understandable by humans while remaining syntactically equivalent at runtime. Identifiers are assigned meaningless names, code patterns are scrambled, and literal strings are encrypted. Runtime application self-protection, RASP, applies tamper, debug check, root check, hook check, jailbreak, date locking, depending on the context. And as you can hopefully see, Dash0 is designed to get up and running relatively quickly and then tweak and iterate on protection settings as required. Plugging into existing build agents is very simple as well, whether it's Dockerized builds for Jenkins or we've got a GitLab, Bitbucket. Preemptive is designed to run in your environment, in your existing CI/CD. There's no need to ship our binaries or our source code to an external server for encryption, then ship back. You have full control over the settings, so you can deploy with confidence knowing you've taken the steps to secure against reverse engineering and tampering. Preemptive works with desktop, mobile, browser, server-side, and IoT. We can envision a browser-based Angular piece with account sign-up and management, or maybe a React Native mobile app with identical functionality to our desktop piece. We'd also use Preemptive to protect these portions of our app, but we'll save that for a different day and time. So I thank you again all for sharing a little bit of your time with me and your attention. Back to you, Michelle.
Thank you for that. We're going to move on to the questions portion. If we can get, we'll get John and Michelle back in here so they can answer any questions you might have. If you have any questions, feel free to just send them in the chat. So I'll get started with this one. Are there any barriers when obfuscating your source code while continuing to build your projects with Spring Boot?
No. The great thing about the way we've designed the preemptive tool set is they're designed to plug into your existing CI/CD. So if whatever we're using to do our continuous integration, if we're using GitLab or Bitbucket, Azure DevOps, we would plug preemptive into our existing YAML file. There'd just be a tweak to call preemptive as part of the step. And we would apply application protection and then deploy how we normally deploy. We don't have to make any sort of adjustments at that point. Once we initially set things up, configure them, and get them plugged into our pipeline, we're all set. We just leave it in there, let it do its thing, and we can go on continuing to code, develop, build upon our applications as we normally would.
Does this have a long setup time?
No, it's depending on the number of apps that we want to apply protection to. One app we can get up and running in minutes. So we have, we saw with Dash0, there's a wizard. We just step through the wizard. It guides us through that process. And that process is designed to literally get up and running within minutes. Once that's done, we have control over the settings. So if we, in most cases, we'll want to make some tweaks and changes along the way. So we'll want to, turn on this particular feature, adjust this feature, add more protection here, dial it back here, in other areas. So we have full control over the settings, and that process can be done iteratively over time. But the initial setup it can be done within minutes, and even as far as taking it directly into our CI/CD pipeline.
Does this protect server side and client server side?
Yeah, absolutely. So we work with all manner of code and all manner of different types of apps, whether it is a mobile app or a desktop app or client side, server side, middleware, doesn't really matter. As with Spring Boot, we're probably Spring Boot is just a piece of the puzzle. We will, in all likelihood, have a client side piece that we maintain as well. So we're going to be doing something with React. We're going to be doing something with Angular for our browser. We're going to be doing something with Android for our mobile clients. We're going to be doing something with Java FX or WPF, or we have some sort of client piece that will get into the hands of our end user as well. So the good thing about preemptive, we can apply those code protection, transforms, obfuscation to client side and server side pieces. So we're fully covered.
Fantastic. It looks like that is all the questions we've had. So I guess we can go ahead and end this. Thank you both again for the presentation. Again, that was John Bronner, Senior Solutions Engineer at PreEmptive, along with Michelle Pruitt, Digital Marketing Manager at PreEmptive. I would also like to thank PreEmptive for sponsoring today's webinar, as well as the attendees for joining us.
Yes, thank you everyone for joining.